Hello students, my name is Priyanka Tripathi and I am going to solve the questions related to the topic symmetrical fault analysis, that is a topic of the subject power system protection. So here, what is symmetrical fault? It is basically the fault which occurs between simultaneously in all the three phases. It can occur in all three phases, or it can occur the three phases with the ground. So uh, these are the basic formulas for related to this topic. The first formula is the percentage of x. Actually, in symmetrical fault analysis or any type of calculation in power system, there basically we consider the percentage reactance of the equipments connected to the power system. As like this is a single line diagram of a power system. So here the percentage reactances are given, because percentage reactances are very much necessary for the calculation of the short circuit current and for the rating of the equipment. So basically for this type of question we have to convert that percentage of reactance at base kVA, because in these type of questions we basically consider a base kVA which will simplify your calculation. So here if base kVA is like this, then first this x is basically the rated kVA. Like if generator has the percentage reactance of 10% and that is on the rated kVA, then it will be called as the rated percentage reactance. But when we are converting this percentage reactance into another base kVA, so we will use this first formula. Okay, then next formula is this, means where x value, reactance value is given in ohm, then we will find that value in percentage of x by using this formula. Then third equation is like this, where the rating of the equipment is given, means kVA rating is given, kV value. This formula is basically an extension of the previous formula. By multiplying 1000 upside and lower side, we can get this formula also. So this is also basically a useful formula, because in power system the equipments have has given the ratings like this. So they have kVA value and kV voltage value. So we will use this formula in that part. Next formula is also important, that is short circuit current. Why we find out the short circuit current in any power system? So the reason is very simple, because as we know that there are different type of equipments connected in the power system. So if any type of fault occurs, in generator or in bus bar or any other places, so that can affect the equipments connected to the system. So we have to know what type of short circuit current that equipment can sustain, so that we can connect that rating of the equipment to the power system. So that's why we calculate always short circuit current. Okay, now the fifth formula is the short circuit kVA for three-phase circuit, that is base kVA into 100 by percentage of x. Okay, so this percentage of x basically what? It is the percentage of x at base kVA. Okay, then again here also it is percentage of x at base kVA. Okay, so there is one equation, one numerical here. The numerical is like this, the section bus bars. Okay, let me explain this thing. Actually the reactors are connected in the bus bar so that we can control the short circuit current. Basically we can limit the short circuit current. So these reactors can be connected with generators, with the feeders connected, or in between the bus bars. So bus bars have two type of connection basically. One is ring system, that means the reactor will be connected in the bus bar, and another is the tie bar system where these reactors are connected with the generators like this. Okay. So this is called basically tie bar system. Now we will come to this numerical. So the numerical is saying the section bus bars A and B are linked by a bus bar reactor that is rated at 5000 kVA and 10% reactance. Yes, so there are two bus bars. One is this bus bar, this is bus bar number A, and this is second bus bar. Now these bus bars are connected with the help of a reactor, and the rating of the reactor is given here. Now on bus bar A, this is the bus bar A, there are two generators. Yes, generator number 1, generator number 2, each of 8000 kVA with 12% reactance. Okay, sorry. One thing is not written here, that is for bus bar A, there are two generators that have 10,000 kVA and 10% reactance. So each of here it will be 10,000 and reactance will be 10%. So another bus bar have also different type of kVA value and percentage reactance. So that is not written here, but in question it is given. So in diagram it is given. So we will consider like this. Now the question is that find the steady MVA fed into the dead short circuit between all phases on B with bus bar reactor in the circuit. So the question is that if this is the bus bar number B, and if there is a fault or short circuit at this bus bar, then what will be the short circuit kVA? What will be short circuit current? What will be the steady state MVA or short circuit kVA for three-phase circuit? So how we will solve this type of question? So here we will use these type of basic formulas. Okay, let us start to solve this question. So first step. So what are the steps to solve this type of questions? Step number 1. First, you have to consider base kVA. Consider base kVA. Okay. What will be base kVA? Base kVA basically it can be three types. So we can consider the largest kVA of the equipments connected in the system. So here it is the single line diagram. If it is not given, like if this theory portion is given and this diagram is not given, then first step is to draw the single line diagram. Then you will choose this base kVA, that can be the largest kVA value of the equipments connected to this system, or it can be the summation of all the equipments ratings, or either you can choose any type of value for base kVA. Okay, then in second step, now the time is to convert the percentage reactance in another base kVA. So convert percentage reactance on base kVA. Yeah, this is another thing. Then third step is to draw the reactance diagram. Why we will consider this reactance value or reactance diagram? Because percentage reactance value is very helpful in calculating the short circuit current or short circuit kVA. So we basically for that we will draw the reactance diagram. This is the third step. Now in fourth step, what you will do, we will just put all the values in these type of equations.